Hello everyone, I have the honor to present to you my work entitled Study of the Influence of Limiting Factor in the Performance of Multi-Junction Solar Cell CGS-CIGS. In this work we have the outline. First we will start with introduction, then material and methods, then result and discussion. We finish this work with conclusion. Photovoltaic conversion is the transformation of light energy into electrical energy. Devices capable of performing this transformation are called solar cells. Their yields were relatively very low, which motivated the study of the influence of limiting factors conversion yield. For this reason, we have studied the influence of factors temperature, parallel resistance, and series resistance on the characteristic IV PV for the performance of multi-junction solar cell CGS-CIGS for 3 modes: tandem, cascade, and dichroic. Multi-junction solar cell can augment the efficiency of the cell by introducing another semiconductor capable of reducing some of the losses by thermalization or by transmission. With this approach, 3 configurations exist: monolithic solar cell, mechanically stacked solar cell, and the multispectral system. In our work, we are interested in the monolithic solar cell. In the monolithic solar cell, we have 3 modes: tandem, cascade, and dichroic. We have chosen for this study a combination of 2 optimal CGS and CIGS cells with a temperature variation from 300 to 400 Kelvin and the change in the following value of the series and parallel resistance. The influence of temperature on the performance of the CGS top cell. The next figures show the variation of open circuit voltage and current density as a function of temperature, and the second shows the variation of fill factor and efficiency as a function of temperature. The next figure shows the influence of temperature on the IV characteristic of the top CGS cell. Influence of temperature on the performance of the CIGS bottom cell. The next figure shows the variation of open circuit voltage and current density as a function of temperature and variation of fill factor and efficiency as a function of temperature, respectively. The next figure shows the influence of temperature in the IV characteristic of the bottom CIGS cell. We have studied the influence of temperature from these figures. We noticed if temperature of the cell increases, the photocurrents also increases. The photocurrents also increase due mainly to the decrease in the weight of the fabrication band of the material. The direct current of the junction also increases, but much faster, and resulting in a decrease in the open circuit voltage, which justifies the decrease in the efficiency supplied. The next table shows gives the values of the efficiency of the 3 modes: Tandem, Cascade, and Dicrowick at each temperature. We noted that if the cell temperature increases, the efficiency will be reduced. Influence of the resistance. First, we will see the influence of the parallel resistance. The next two figures, the influence of parallel resistance. The next two figures show the influence of parallel resistance on the characteristic IV of the top and the bottom cell of the CIGS multi-junction. The parallel resistance or shunt characterizes the losses by recombination of carrier due to structure defect of the material thickness on the N and P region and of the space charge zone. We choose for this study a combination of two cells, CGS and CIGS, at temperature equal 300 Kelvin and illumination equal 1000 watt per square meter and a serial resistance equal 0.5 ohm with a parallel resistance value. The influence of parallel resistance on the characteristic IV and PV of each independent solar cell is shown in the figures. The parallel resistance is directly related to the manufacturing processes, and its influence in part only for very low values of the current. The next table gives the values of the efficiency of the three modes of multi-junction solar cell at each value of the parallel resistance. We noted that if the value of the parallel resistance decreases, the efficiency decreases. Now we will see the influence of series resistance in the top and bottom cell. The series resistance characterization the losses by Joule effect of the intrinsic resistance of the semiconductor and the losses through the collection gate and the bed ohmic contact of the cell. High resistance semiconductor electrode contact scientifically lower the output voltage and current, which will limit the conversion efficiency. The influence of the series resistance on the characteristic IV of each independent solar cell is shown in the figures. According to these figures, this influence results in a decrease in the slope of the curve IV in the area where the cell operates as a voltage source to the right of the point of maximum power. The next table gives the efficiency values of the three solar cell multi-junction nodes at each series resistor. Noted that if the series resistance increases, the efficiency decreases without causing an almost negligible small losses in the efficiency. In this study, we are interested in the influence of limiting factors and the performance of multi-junction solar cell CGS, CIGS with different modes of comparison for the optimization of tandem film photovoltaic structure. The influence of resistance, series and parallel, and the temperature on the efficiency of the multi-junction solar cell for the three modes are important. When the temperature is changing, the voltage VOC increases while the current is decreases. The performance of photovoltaic cell is even more graded when series resistance is big or parallel resistance is